JMath.
Welcome to a lesson on grade 10 number lines. So this is a concept that you will use till the end of matric, so please focus in this lesson. You can see on screen now the whole number system. We're going to discuss this in a bit more detail, and then we're going to check number lines. So let's start. The very first numbers you learned naturally were the numbers 1, 2, 3. Whether you were counting your blocks, your toes, or your toys, that is what your mom told you. And these numbers are called the natural numbers. Then later at school, you learned about the numbers 0, and they are now called the whole numbers if we add them. After that, in grade 7, we expanded another number line into the negative side. And those numbers, including the negative numbers, are called integers. So it doesn't have fractions or decimals, but all your whole numbers, including positive and negative, are called integers. The next group you only learned in high school is called rational numbers. So it includes natural, whole, and integers, but with them is all your fractions, but the easy fractions. So fractions that you can write it with a numerator and a denominator, or decimals that repeat, recurring decimals, or decimals that stop. So 0.125. Those are all called rational numbers. Now, please remember, it includes all the normal numbers that you also learned. So when you get questions about is this a rational or irrational, remember you must look at the whole group and not just say, oh, it's just fractions, that's rational numbers. So now we're going to look at irrational numbers. So this is now the opposite of rational, and those include any decimal that's not recurring and that doesn't stop. So that would be pi, the root of something that's not a perfect square, or the cube root of something that's not a perfect cube. Any decimal that doesn't have a pattern and doesn't stop is called irrational. So here we can just look at a summary of what we just discussed on the number line. So natural numbers, we write with the n, and that's just 1, 2, 3, 4, 5. Whole numbers is when you add a 0, and then again, no decimals, no fractions, just whole numbers. Integers, that whole list of whole numbers, but now we also go into the negative side. Okay, so remember, integers include all the whole numbers, which includes all the natural numbers. Now, so rational numbers, as you can see, includes all your integers, all your proper fractions, improper fractions, and mixed numbers. Then with decimals, just two types, the type that ends, so short decimals, and then recurring numbers. Those all fall under rational numbers. Now with irrational, that is the ones where it doesn't have a pattern. So if I give you a number now and I say 3,5, 6, 7, 8, 9, 3, 5, 2, 9, and at the end of this video, I ask you, what's that number that I repeated? Like, I can't even remember the number I just said. It's not rational. Doesn't make sense. There's no pattern. It's too long. That's what an irrational number is. So you can remember it is all your surds or square roots of non-perfect square numbers, and also cube roots or quad roots or all of those. And then the special one is pi. So all of those I just mentioned falls into irrational numbers. Now, what's very important is you must not confuse this. Irrational numbers are still numbers. They do exist. Your calculator can show you irrational numbers, and that's why point number 6 says all real numbers consist of rational and irrational numbers. So the way I always teach it is if you can type that number on your calculator, or your calculator can give you that answer as an answer to the sum, then it is real. Okay, now that sounds very weird because like that's all numbers in math. But no, there are certain numbers that's non-real. And those are the numbers that your calculator cannot show you. So in this case, it is the negative square roots or the negative of any even root, so a fourth root or a sixth root, and then all your undefined numbers. So anything you divide by 0 would be considered as non-real. My calculator can't show that number to me, and therefore it doesn't exist, and therefore it's non-real. Okay, so now just a little star I need to put next to this. I am teaching this as pure math, not as AP math, because in AP math, you get other numbers that's also part of this list. And then the negative square roots falls into complex numbers. But for the purpose of this video, we are not going there. Now, just as a visual aid, so just look at this. We start in the middle, so that's where your natural and your whole numbers are. Then if I just zoom out a little bit, that's integers. Then terminating recurring decimals forms part of your rational numbers. And then the outside circle is your real numbers, which once again includes rational and irrational numbers. So all of this is the real number system. Guys, you must please memorize this. There's until matric, you're going to get certain random questions on this. It's never going to be 40% of your exam, but you do still need to know this. Now we're going to number lines. So that's something that's very prevalent in grade 10, but not as much in 11 and 12. So it's easy marks. So let's make sure you get those marks. Now, the first thing, we can use two types of notation. So set builder notation or interval notation. In the first part, this is written in set builder notation. So they are just telling you, you're going to use an x. X is part of the integers, and then they're going to tell you something about x. So if we look at the first one, they are telling me I'm working with x, and x are all my integers that's bigger or equal to 2. Okay, now something you need to know is if we are including a number, we are using a dot. Okay, closed, colored in, black dot. Okay, now with integers, it's always just going to be a closed dot. When we get to the real numbers, then there's other variations. So in this number line, I'm just going to make a dot on 2 and 3 and 4, and then I'm going to make a little arrow pointing to the bigger than side. So it goes all the way till 100, a million, and then infinity. The middle one says x is now part of integers, which is smaller but not including 3. So in question 1, they did include 2. So I must put a dot on 2. But in question 2, they did not include 3. So that's why I'm only starting at 2, and then I'm going to the left because it said smaller than. Okay, so watch closely for that one. And then the third one says between -1 and 3. Look closely. -1 is included, but 3 is not included. So I'm not going to put a dot there. Make sure you read very carefully in your test. These are easy marks, but it's also easy to make a little mistake. Now we're going over to real numbers. So integers does not include decimals. So I only need to make dots on the actual numbers. But with real numbers, remember that's 0,1, 0,01, 0,001. I can never put a dot on all of the decimals. So therefore I draw a line between them, which means I'm including everything between these two numbers. Okay. Now, when we work with real numbers, it's normally written in interval notation. And in interval notation, as you can see in these two blocks below, included is a block bracket and not included is a round bracket. And then with the dots, included is a colored enclosed black dot, whilst not included is an open circle. Okay, question 1 says, I am including all real numbers from -2 till 1, and both of them are included. So that's why I'm making a closed circle on both of those numbers and then just drawing a line between them. This is really easy, guys. So you're always just going to make the two circles and just connect them. You must just check if it's open or closed. Okay, so you can check number 2, which says none of them are included. So I'm making 2 open circles. Number 3, the first one's not included, but the second one is included. That's why it's looking like that. Now with the last two, there's an infinity. So if there's an infinity, you make your dot or your open circle on the number that they tell you, and then you just draw an arrow to the correct infinity. So with number 4, it's -3, and then it goes until positive infinity. That's why my arrow is pointing to the right. With number 5, it's now from -infinity all the way till 2, but we read it from the middle, so I'm going to start my arrow at 2 and then draw to the left to -infinity. I hope this makes sense. Let's now look at a few examples, and then you must please try them. So you can pause the video here, try them, and then see if you were correct or not. Question A, x is greater or equal to -3, and x is a part of integers. So that means I need to do dots and not lines. So I am actually just going to copy this and then paste a few of these circles. So if I say that was -3, then I'm just going to do about 3 dots. That's enough. So if this one is -3, this one would be -2, this one would be -1, and then I'm just going to make a little arrow saying it's continuing all the way to the positive side. Question B, again, I need to paste a few extra dots. Very important with this one, -2 is not included. So my first dot's actually on -1, 0, 1, 2, 3. And for that, I will get full marks. Let me just erase the previous question so you can just see that is all I need to do. There's no arrows. It's just those dots. Okay, so now with question C, I can see that -3 is not included, but 2 is included. So I'm going to do an open circle, then a closed dot, and then I'm just going to connect them with a line, and that's how I would get full marks. Question D. So interval notation, and they're telling me x is an element of, if it's interval notation, always real numbers, and then -4 until 2. But -4 is actually not included. So I'm going to do a -4 there, and then all the way to 2, and then just connect them. I am just seeing I forgot to write -3 and 2 for the previous question. Sorry about that. Question E, from -infinity up until 3, so I know that's a 3, and then -infinity goes that way. And for that, I will get full marks. Now they're flipping the question and they're saying, but I'm giving you the number line, please do the interval notation. So remember, closed dots is block brackets, open circles, round brackets. So I know I'm going to say x is an element of block bracket -1, and then all the way till 4 block bracket. Question G. So now it's a 0 and an 8. I can see that. I know it's x is an element of. And now I'm going to do block bracket, round bracket. Question H, the last one. X is an element of block bracket for 2, and then infinity, round bracket. Okay, perfect, guys. That was the number system. I hope it made sense. Please leave me a comment if I need to explain something better or if you want more practice on this. But I do think this is pretty plain and simple.
If this video helped you, please like and subscribe.
JMath.